Welcome to clickmyproject.com. Now we are going to discuss about the product heartbeat rate measurement from facial video. Now we are going to discuss about the abstract for the process. Heart rate reveals a person's health condition. This paper presents a effective system for measuring heart rate from facial video acquired in more realistic environment than the testing environment of current systems. The proposed method utilizes a facial feature point tracking method by combining a good feature to track and a supervised descent method in order to overcome the limitation of currently available facial videos from heart rate measuring systems. Such limitations include, for example, unrealistic restrictions of the subject movement and artificial lighting during the data capturing. A face quality assessment system is also incorporated to automatically discard low quality faces that occur in the realistic video sequence to reduce the enormous results. The proposed method is comprehensively tested on the public datasets available, that is the MAHNOB database and our local database which is created by us, which are collected in realistic scenarios. Experimental results shows the proposed system outperforms existing video-based system for heart rate measure. Hence, this process is well efficient and reliable for the dataset videos and the dataset signals which we have collected. Hence, the process is more efficient by the comparison of the other existing systems. Now we discuss about the flow diagram for the process. Here the process is structured into, that is divided into two stages. First one is by the video process, then the second one by the signal process. At first, the video is taken from the dataset. The dataset consists of the several face videos. After getting the input video from the database, the frame conversion is carried out. Frame conversion is nothing but converting the video into sequence of image. That is known as the frame conversion. After the conversion of the video into image, the pre-processing is carried out. In this pre-processing module, we have the three steps. First one is the filtering, then second one is the resize, then the third one is the illumination detection. In the filtering stage, we have to remove the noise from the frames. When the noise is occurred means the filtering will remove the noise. After the filtering process, the resize is carried down. In the resize process, the each and every frames are resized into an aspect ratios. After the resize, the illumination detection is used to correct the illumination rate in the image. If the illumination of the image is low means the illumination will be boosted up. After the illumination correction, the face detection will be carried out. In this face detection module, the violations is applied to detect the face region, and then after extracting the face region, the feature extraction is carried out by using the GFT and SDM. After extracting the feature values, the classification is done by using the classifier. When the classification is done, there is the another step, the data acquisition, like ECG data acquisition. After the ECG signals getting from the dataset, the pre-processing is carried out by using the filtering method. Then the heart rate calculation is done by the PCA and DCT. After the heart rate calculation, the feature is extracted in the signals. Then the classification is done for the signal and the video. After the classification result is shown in the message box. Now we discuss the initial running procedure for the process. At first open the MATLAB 2013 and change the current directory. If you want to execute the code means just right click in the mainfile.m file and select the option run. Now you can see the folder video. Open the folder video and select the video from that folder. After the selection of the video, the process will be done automatically. The input video which I have selected is shown in the figure 1. Then the figure 2 represents the frame conversion. In the frame conversion module, the input video is converted into the several images. Now the process is done automatically. Now here we want to enter the signal number. Now I can give the signal number as 3. Now the signal is imported and then the feature is extracted from the signal and then the classification is done. Now I discuss the results one by one. Now the figure 1 shows the input video, then the figure 2 shows the frame conversion. In the frame conversion module, the video is converted into the sequence of images. Then the figure 3 shows the grayscale video. Then the figure 4 shows the illumination video. Then the facial points are plotted in the figure 5. The blue color points represents the facial points. At last the illuminated video is shown in the figure 98. Now the binary image is shown. Then these are the results for the clustered image. The clustered image, the face region is extracted and the remains backgrounds will be eliminated. Hence the input signal is shown in the figure 6. Then the denoised signals are shown in the figure 7 and the figure 8. Then the peak value, that is the feature extraction, is shown in the figure 9 and the performance analysis is shown in the last in the command window. Now the signal is normal.
Thanks for watching this video.